Hey guys, welcome to Pre-Calc lesson 7.5, arithmetic and geometric applications. Our first example here, we have a hay loft. It's stacked such that the top level has 26 bales, level 2 has 33, level 3 has 40, etc. How many bales are in the 15th level? What I always like to do here is just start writing this in expanded notation. So a sub 1 equals 26. A sub 2 equals 33. A sub 3 equals 40, so on and so forth. So next, let's identify what type of sequence is this. Well, what I need to do is figure out what am I doing between each term here. It looks like I'm adding 7. Okay? So it's arithmetic. My initial value, or a sub 1, is 26, and d is 7. And I want to know how many bales are in the 15th level. So that's going to be a sub 15. Well, that's going to be a sub 1, which is 26, plus d, which is 7, times 15 minus 1. I'll write it out, or you can just plug in 14, obviously. That's going to give me 124. Then it says if the whole loft has 25 levels, how many bales does the loft hold? So how many bales does the loft hold? That's a sum situation. I want the sum of the first 25 levels. Well, my sum formula I know is n divided by 2, so that'll be 25 divided by 2, times a sub 1, or the first number, 26, plus, well, what I need to find here is a sub 25, because there's 25 levels. So over on the side, let's find a sub 25. That's going to be 26 plus 7 times 24. And if I throw that into the calculator, that gives me 194. And that just goes here. Now I throw that into the calculator. 25 divided by 2, so 12.5 times 26 plus 194. And doing that, I got 2,750. So that's how many bales would be in the whole loft. Our next example, a 2005 Mustang convertible is purchased brand new for $42,000. It depreciates at a rate of 4% per year. So before we get into this problem, I want to review appreciation and depreciation, right? Percent increase, percent decrease. And just remember that a percent decrease equals 1 minus the percent. So in this case, if the percent is 4, it's going to be 1 minus 0.04 or 0.96. So anytime you're dealing with percent increase, percent decrease, you know it's geometric. And it says write the car's value for the first 5 years in expanded notation. So every year you multiply the value by 0.96, and that's what the depreciated value is. Okay, so let's write out the first 5 years. A sub 1, that's just your 42,000. A sub 2 is going to be 42,000 times 0.96. What I get for that? I got 40,320. A sub 3 is going to be that, 40,320 times 0.96. And for that, I got 38,707.20. A sub 4 is going to be that number, 38,707.20 times 0.96. Rounding to the nearest cent there, I got 37,158.91. And lastly, a sub 5 is going to be that 37,158.91 times 0.96. And that was, let me see, 35,672.56. So there's expanded notation. It says find the nth term rule for the sequence. Okay, so what do we know? We know a sub 1 is 42,000. We know r is 0.96. So my a sub n rule, a sub n equals a sub 1, 42,000, times r, 0.96 to the n minus 1. And what will the value of the car be in 2015? So when did we buy it? We bought it in 2005, and I want the value in 2015. So obviously here, n equals 2015 minus 2005. Pretty straightforward. That's going to be 10. So a sub 10 equals 42,000 times 0.96 to the 10 minus 1 or 9th power, and that gives me $29,086.43. Our next example, a law firm offers a prospective employee a starting salary of $55,000 per year with a minimum yearly raise of $1,600. What would the minimum salary be for the new lawyer after her 15th year with the firm? Okay, so what's happening here? She starts at $55,000, so I know that's a sub 1. A yearly raise of $1,600. Now, are we multiplying or are we adding? Well, if the raise is $1,600, we are adding. So that's going to be D. This is arithmetic. What would the minimum salary be for the new lawyer after 15th year with the term? I want A sub 15. What's it going to be that year? That's going to be A sub 1, 55,000, plus D, 1,600, times N minus 1, or 14. And throw that into the calculator, I got 77,400. So it's just a straightforward substitution into our arithmetic formula. Now this question, notice what it says, what would her total earnings upon retirement be after 25 years? So total earnings, that's a sum formula. So what I need to do this, I need the sum formula after 25 years. Okay, well that's 25 over 2, remember this is arithmetic, times A sub 1, so what'd she start at? She started at 55,000, plus A sub 25. So what I need to do is I need to find A sub 25. Unfortunately, it's not the same result as what was up above. That was A sub 15, so I need to recalculate this. 55,000 plus 1,600 times 24. And let's see, I got 93,400. So that goes right here, 93,400. And then just simply plug all that into the calculator. And total earnings I got was 1,855,000. So that's how much she earned over the 25 years. All right, our last question is kind of a tough one. It says here, a ball is dropped from an initial height of 20 meters, and on each successive bounce, it rises to a height of 80% of its previous height. So I'm going to try and sketch this as best I can here. I've got a ball, drops, and then bounces. And it keeps doing this. And each time it bounces to 80% of its previous height. All right, so there's a couple ways you can approach this. All right, what is a bounce? A bounce, in my opinion, is when it hits the ground. So how high does the ball rise on its sixth bounce? So what I did here is I designated this as A sub 1. And then I did that as A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, A sub 7, A sub 8. So the A represents the height of the ball. And there's a couple different ways you can do this. It just depends on your frame of reference. So how high does the ball rise on its sixth bounce? Well, here's the first bounce, 1, 2, 3, 4, 5, 6. So after it is bounced 6 times, how high does it rise? That's going to be this. That's A sub 7. So what I'm looking for is A sub 7. All right, so what information do we have here? What's A sub 1? A sub 1 is the initial height, 20 meters. What's happening each time? It rises to a height of 80% of its previous height. So that's an R value, 0.8, 80%. So if I want to calculate A sub 7, I simply take A sub 1, which is 20, times 0.8 to the n minus 1, or to the sixth. Okay, and what did I get there? I got 5.24288. I went way out in decimal places. That's how high the ball is after the sixth bounce right here. That's that height. Now, that's not too bad. This next question is where it gets challenging. It says, what is the total distance the ball has traveled at the moment it hits the ground for the eighth time? Okay, well, let me keep going here. So that's 7 and that's 8. So now what I need is how far has this traveled by the time it gets here? So I want this whole distance. Well, that's going to be a little bit challenging. So if we take a look now, again, this is kind of represented over time. It's not distance. I'm not throwing it forward. It's just dropping. So it's going down, up, back and forth. So really what I need to do is I need to get all of these heights here and add them together. Well, one approach is to take the sum of the first 8 terms, right? So if this height here is 20, and that's 80% of it, so that's 16, and that's 80% of that, 80% of that, so on and so forth, I need the sum of the first 8 terms. Well, that's not too bad. Sum of the first 8 terms, this is geometric, so that'll be 20, the initial height, times 1 minus 0.8 to the 8th, all divided by 1 minus 0.8. That equals 83.222784. Again, I didn't do any rounding here. But what does that really represent? That represents this height here for each one of these. Or it represents how far the ball went down. So that's the descent distance. That's that sum. Okay, just those. So that is the descent distance. So what else happened? Well, the ball also went up each time. So now what I have to do is I have to add these in. Well, how many of those are there? You could do a whole new sequence, or you can realize, well, hey, this distance here, all of these, is simply going to be this distance minus that one. Because the ball didn't go up to that height, it was dropped from that height. So the easiest way to do the ascent distance, in my opinion, let's see, sorry, I can't spell. Ascent distance is simply going to be that 83.222784 minus 20. So that is 63.222784. And then your total distance is simply what you get when you add those together. So that's your 83.222784 plus 63.222784. And let's, let's round this to the nearest hundredth. So I got 146.45, and that'd be meters. So kind of a challenging problem here. I don't know if you'll see this again on an exam, but kind of a neat application of geometric sum and our geometric a sub n formula. Okay, guys, that's it for day 5, our application day. Thanks for watching. Please reach out if you have any questions. We'll see you in class soon.